All right, so 5, 4 equal, oh yeah. All right, so again, 5, 4, 5, 4, sorry, is isosceles equilateral triangles. So parts of an isosceles triangle, these have like specific names. The two sides that are congruent are the legs. So these are the congruent sides are called legs. The non-congruent side is called the base. The angle where the two congruent sides meet is called the vertex angle. And then the other two angles are called a base angle. Base doesn't always necessarily mean bottom. Like I could take this triangle and I could turn it on its side, and the two sides that are congruent would still be the legs. So these two would be the legs. This would now be the vertex angle. The left side would be the base.
Wait, for the base? Are the two angles within it the same?
They're going to be the same, yeah, which is one of the theorems we're going to learn. And then these two would be the base angles. So again, base doesn't always mean bottom. Base means the non-congruent side. The base angles theorem, which has a name so we can use it, says if two sides of the triangle are congruent, then the angles opposite them are congruent. So if I've got my triangle and I've got the two sides marked as congruent, then the angles opposite them are also congruent to each other. So if AB is congruent to AC, then angle B is congruent to angle C, and we would say that that is the base angles theorem. Okay, the converse of the base angles theorem, which converse means switch the order, right? So if we switch the order on that, now we're saying if the two angles of a triangle are congruent, then the sides opposite those angles are congruent. So now we're using the angles first. So you'd be given that the two angles are congruent, and if that's the case, that the sides opposite them would be congruent to each other. And again, it has a name, but you have to differentiate between the original base angles theorem and the converse of the base angles theorem. I don't care if you say converse of base angles or base angles theorem converse, but you got to make sure that the converse is in there if you are trying to prove the sides are congruent. So if you're given the sides and you're proving the angles, that's the regular one. If you're given the angles so you're proving the sides, that's the converse. Okay, remember corollaries. Corollaries are something that's easily determined from what you already know from those theorems. So the corollary to the base angles theorem, and honestly, it takes less time to write out what it says than that name. So I wouldn't stress too much about the name.
Corollary to the base angles.
Correct. It says if a triangle is equilateral, then it's equiangular.
Well, that's obvious.
That's why it's something that's easily determined from, yeah, corollaries are usually
but
pretty.
If I need to prove, there's never enough room for me to write.
Oh, write smaller.
It's an excuse.
My pencil is not that sharp to
And
write that
people
small.
figure it out all the time.
Mrs. Chris Wiley.
Yes, sir.
So what's the point of corollaries?
It's just something that you can easily, so like you could actually prove this every time, because if the triangle has all the three sides that are congruent, then all the angles opposite those would be congruent. So you could use the converse of the base angles theorem, or you could just say if it's equilateral, it's equiangular, and vice versa. Corollary to the converse would tell you that if it's equiangular, then it's equilateral. So if you're trying to use these in a theorem, instead of using that, in a proof or something like that, or justification of your steps, instead of writing that big whole thing out, you could literally just say, if it's equilateral, then it's equiangular. If it's equiangular, then it's equilateral. Okay? You don't have to write out the name. All right, so now let's apply some of that stuff. This says find the value of x. So if I look at A, what are you given about the sides?
The sides, the angle is 30 degrees.
What are you given about the sides?
That they're equal.
Those two sides are equal. If those are equal, then what, Nick?
Then the other side also equals x.
So these angles would be equal, right? So this is x. So what's true about all three angles in my triangle?
They equal 100.
They add up to 180. So if I did 180 minus that 30, I'd get 150. And that's split between those two, which means each would be 75.
That's pretty easy. whole chapter just triangles with two?
Sections, the section you mean?
Sorry,
Yeah.
Is it all triangles with two?
No, well, it's
Or is it all isosceles triangles?
no, it's isosceles and equilateral. All right, go to B. Now you're given stuff. So the biggest mistake people make when they see these is they add them up and they set them equal to 180. What's wrong with that? It's the lengths, not the angles. So like there's no set value about the outside lengths, right? Unless you had perimeter, right? You would have no relationship between all three. What we do know is that these angles are equal, right? So the base angles converse says if those angles are equal, then the sides opposite them are equal, which means the 2x minus 4 is going to equal the x plus 5. And they do give you extra information in there to throw you off. So subtract the x, and then you get x minus 4 equals 5, and you add the 4, and you get x equals 9.
What about the base?
It's literally thrown in there to throw you off. Because if they only gave you the two side lengths, it'd be super obvious which ones you're setting equal to each other.
X equals 9.
All right.
Wait.
Yeah. You're given two of the angles inside the triangle, right? But they are not equal to each other. What can I do with those two angles, Jonathan?
Find the missing angle.
Good. So
62.
good. 56 plus 62 is 118. Subtract that from 180 because that's how much all three would equal. And you get 62. Now I've got two angles that are congruent, which means the sides opposite them are congruent. And x equals 42.
Wait,
So-
can you repeat?
Yep. So are you good with how we found the 62?
No.
So the missing angle at the top, right? All three have to add up to 180. So you add the 56 and the 62 together and then subtract it from 180 and you get the 62 at the top. And then because 62 and 62 are equal, the sides opposite them, which would be that one and that one, are also equal. All right, example 2 says place the statements in an appropriate order for a proof and then provide the reasons. So we're actually going to do the left side and then give the reasons for it. Okay, but obviously we're now using these isosceles triangles. So if you're given that angle 1 equals angle 2, which is out here, you're trying to prove that OK equals OJ. So before you get even into the steps of it, does that make sense that they would be equal?
Yeah.
If I worked backwards, if I needed to prove that these two sides were congruent using what we've done today, what would I need to know that those sides were congruent? What would lead to that?
The angles?
If the angles are congruent. So if I'm working backwards, would want to get that 3 and 4 are congruent. And what do you know about those?
That they're vertical angles.
Good. So we're going to work backwards from that, but that's the overall idea, okay? We're going to start with which one is my given?
So angle 1 is congruent to angle 2.
Good, which is D, right? So D goes first. D. Angle 1 is congruent to angle 2, and my reason is given.
Why is it step E?
Because that's how it's labeled there. Like you're putting these steps in order.
Oh.
Yeah. So number 1 would be that.
I like that. You should do that on the next quiz and test.
Thank you for your feedback. Okay, now where could I go? Yeah.
A, angle 3 equals angle 4.
You're missing the step in between there though, right?
Wow.
We said it, but we didn't put it.
Huh?
How do you know 3 equals angle 4 yet?
Oh, B.
B, you're going to do the vertical angles first.
Oh.
Good. So B is that 2 equals 4 and 1 equals 3. And that's the vertical angles theorem, or VAT. It has to be the theorem, not just the definition. Yep.
B would be 3. Or no, A would be 3.
Now you're going to A, because we have angle 3 is equal to angle 4. And how do you know that?
I feel like I said transversal, but I feel like it's going to be substitution.
It is good. It's substitution because you're not replacing this same angle, right? We said 1 equals 2 and 2 equals 4, so you can go to 1 equals 4, but then you have to go 1 equals 4 and 4 equals 3. So it could be 2 transitive statements separated out, But because we've done it together as one, that would be substitution.
That's why I got it wrong.
Yeah.
What's the difference between angle 3 is congruent to angle 4 and angle 3 equals angle 4?
There's really no difference unless you're using the definition of congruence, which we're not even worried about right now. So if they give you those steps, then the reason is definition of congruence, but if they don't give you those steps, you can go back and forth between those.
Subtraction.
No, that says substitution. It does look weird, but that says substitution. Yeah.
4 is because of the converse to base angle still.
So 4 is OK to OJ, though it's left, right? And that's the converse, good. To the base angles theorem.
Can we just say
Base angles theorem, converse, that's fine too, yep. Questions? All right, last one, and now it's a proof that's empty. So it says M is a midpoint of AB, and angle 1 equals angle 2. Prove that AC equals MB. So again, kind of work your way backwards. If I know I want to prove AC equals MB, what would I have to show before that?
That 2 is vertical.
Before I get there. How do I go back from there? Yeah, like what proves the sides are congruent?
And 2 and 1 are equal.
That the angles opposite them, those base angles, right? So I got to get that 1 and 2 are congruent. And then I have to get, sorry, wait, I labeled the wrong ones, right? Yeah.
It's the angle.
Then I would eventually get the AC equals MB, and that's where the midpoint comes into play. So I'm going to start with the midpoint one. M is the midpoint of AB, and angle 1 equals angle 2. And that's my given. I can already mark angle 1 and angle 2. What does the midpoint mean? What does that tell you, Jonathan?
That is the exact middle of it, or the 2 sides equal the
Okay, good. So I could say AM equals MB. So this equals this. And that's the definition of a midpoint.
Why is given say number 2?
Why does given say number 2? Oh, there.
Oh, what do you see?
Is there police?
All right, now I've got that those two sides are congruent. Next, Jonathan.
AM equals AC.
AM equals, say it again,
Yeah, AM equals AC.
equals AC. And what's that reason?
I put base angles 3.
Good. AM equals AC. Base angles theorem. Converse. And now since they both equal AM, can I link them together? Yeah. So AC equals MB. And this time it's transitive. Yep, because they both equal the same side. So if MB equals AM and AC equals AM, then AC equals AM. Or AC equals MB, and that's transitive.
I forgot it was transitive. I put transition.
Oh.
You're supposed to.
Rookie mistake, buddy. Rookie mistake.
Sorry? Yep. You're gonna learn 2 more shortcuts. So up to proving triangles that are congruent. So up till now we only had side angle side, which made the quiz a little bit easier because you only had 1 to choose from. Now you're gonna by the time we get to test there'll be 5, but you're gonna learn 2 more in this section, and that is side, 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 and HL, which stands for hypotenuse leg. So side, 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 to me is like the most obvious one. It is all 3 sides of one triangle are congruent to all 3 sides of another triangle. If that happens, then the 2 triangles are congruent, and we would say SSS, or side, side, side. So example 1 says to decide whether the congruent statement is true, and then explain your reasoning. So if I look at these 2 triangles, it says DFG is congruent to HJK. Is it true?
Yes.
Yes, and the reason,
SSS.
side, side, side. Okay. You do want to pay attention to the order of the letters, though. Don't just look at that and say their two are equal, because they could give you letters that are in the wrong order, so be careful. If it says DF, then I'm saying the side that has the 2 tick marks, and then FG comes next, that's the side with 3 tick marks. So does that match on the other side? HJ, yes, and then JK. So be careful, because the order of the letters are important. If it just gives you the diagram and it says, are these congruent? And you say yes, and it says give a statement of congruence, then you have to be careful with your order of your letters. Those can be arranged differently, but when you, if I rearrange the first name, it has to be rearranged on the second one too.
But can I have a go at this?
Sure. Like you're going to rearrange them?
Yeah, so, no. DG, HK are congruent.
Yeah.
And DF and HJ are congruent. And then FG and JK are congruent.
Yeah.
So then it'll be wait, what?
I don't know what you're doing. I thought you were rearranging the letters.
Oh, no.
Go ahead.
What are you
You're just saying if you were doing as a proof?
No, I'm just practicing.
Oh, I understand. Okay. So if I were to rearrange the letters, if I did D, G, F, right? Then what would be the order of the letters from the other side?
H, K, J.
Good.
Oh, that's easy.
So just be careful and pay attention, okay? Because the order of the letters are important. All right, number 2, decide whether the congruent statement is true. Explain your reasoning, Jonathan.
They're not,
Why not?
because AB doesn't equal BC.
Good. Not congruent. Okay, this would have to equal this because you have the shared side. So if I was going to use that shared side in a proof, what would be the statement? If I said that equaled itself, what's the reason?
Wait, how is this not congruent?
Reflexive.
That's reflexive. Because I have the 9 that's part of both, that would be one pair of sides. I have the 7 that's part of both, that would be a second pair of sides. But then the 3 and the 4 are not equal.
Oh.
Yeah.
Duh.
Example 3, decide again whether this statement is true. Triangle P or QPT is congruent to RST. Mars.
That is a true statement.
And why?
Because all 3 sides are congruent.
So side, side, side. Good. All right, example 4 says again, explain this time why the bench with the diagonal support is stable while the one without the support can collapse. So here's some application of why it would be important. Yeah.
Because you can see in the first one when the triangles are the same.
So what does that help? Like, what does it help to make them the same?
The line.
More stability.
Basically, these outer sides can never change, right? They can never go side to side, and that would change the lengths. Whereas the one on the right, this could easily shift, right? Like I could slant this whole bench to the right or to the left, right? Because it's not fixed in place. But
Yeah,
these two triangles, which would be congruent triangles, are always going to hold in place because those two sides on the outside can never wobble. They would be stuck to the same.
Yeah,
So you can say that in any kind of wording you want. You can say that diagonal holds the outer two so that they are steady. You could say that it can't slant. You could say it keeps those congruent. Anything like that would be your explanation for why it would be more stable. Yes.
Would be a question like this on the quiz or test?
We have not made the test, but I'm going to go with no on that one. Probably not.
Can I say
Yep.
that the congruence would keep everything in place?
Sure.
Yay.
Yeah.
I don't know what to say.
What does this have to do with?
Now you gotta do mine.
It's just because you are making two equal triangles. That's why it is that perfect shape. Those congruent triangles is what makes that into that perfect shape.
Oh, you don't know if that was on the right or left.
Right. All right. Parts of a right triangle. So, remember you're supposed to warn me. It's too late. It's too late. All right. Parts of a right triangle. Okay. Obviously, the next shortcut involves right triangles. So, just as a review, in a right triangle, obviously you have a right angle, the side opposite that right angle is called the hypotenuse, which also happens to be the longest side. And then the other two sides are referred to as legs. So it doesn't matter which order, they are both legs. So not opposite the right angle, those are both legs. So the HL theorem, or the hypotenuse leg theorem, because that's what that stands for, says if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then the two triangles are congruent.
So basically it's saying that if they're the same, then they're congruent.
If what's the same. So example 4 has you mapping this out on a chorded plane. It says JKL has vertices -3, -2. K0, -2. And L, -3, -8. And RST has vertices 10, 0.
All right.
10, -3, and 4, 0. And you want to show that these triangles are congruent.
You just count with your head, don't you?
You can for the legs, right? So like if it said specifically how to prove it, then like if it said prove it using hypotenuse leg, then I would have to use the distance formula on the hypotenuses. However, okay, if these are, first of all, I'd have to show that where they meet is a right angle. How would I know that this is a right angle over, like where that J is? How do I know this is a right angle? How do I know that's a right angle?
Because
Their two legs go on the line and don't have the best slope.
There's a special word for that little spot.
Rigid.
They're perpendicular. One of those lines is horizontal and one of those lines is vertical, right? So their slopes would be opposite reciprocals of each other. Those would be perpendicular. So I know that there's a right angle in each of those corners. Are all right angles congruent? Yes. So I have a pair of angles marked as congruent already. Then I can use my horizontal and vertical sides to literally count. So 1, 2, 3, 4, 5, 6. And then 1, 2, 3. If I do the same on the other side, 1, 2, 3. And 1, 2, 3, 4, 5, 6. So I have two pairs of congruent sides and the angle between them. So are these congruent? Yes, right? How do I prove they're congruent?
Oh, it's not there, but I wanted to ask, are they congruent because they have reciprocal slopes of like hypotenuse?
That's what makes them perpendicular. But they can be, so hold on. Because what we have right now is actually side angle side, right? Two pairs of congruent sides and the angle between them. This is not hypotenuse leg. This is side angle side. They're still congruent because I can use either one. But if it wanted you to prove that they were congruent using hypotenuse leg, I would need to know that they're perpendicular, so I have to have the right angle. I'd have to know one of those legs, not both, but one pair of legs, like I could have just counted the 3 and the 3. And then I'd have to use the distance formula on the hypotenuse to show that they're congruent. So if it said, prove that these are congruent using hypotenuse leg, I'd have to use the distance formula. But because it just says show that they're congruent and we have the prior knowledge of side angle side, I can certainly use side angle side. To find that missing side?
6 squared plus
Yep.
4 squared equals C squared, and then you write it down.
Yep.
Then equals C squared.
Yep. Yeah. But you don't even need to go that far because we have side angle side, right? But if it had said hypotenuse leg, then yes, you could also use the Pythagorean theorem. We just haven't refuted it yet. Yeah, don't worry, we're going to get back to it, but yeah. All right, this one says, is there enough information given to prove that the triangles are congruent? If there is, state the postulate or theorem. And that says F, G, H, and H, J, K. I know it's hard to see. Okay, so tell me what we know about these two triangles. Why?
Because of the marks.
What kind of marks? So the right angle tells me that I can use that angle as either a congruent pair of angles or as my right triangle. Okay, what else is marked as congruent? This side, which is a leg, right? And the hypotenuse. So this would be hypotenuse leg. Yeah. Bye, Sophia. Have a good day. No, you can't say side angle side because it's not the angle where the two sides meet. So if this was marked congruent with that, now it's side angle side. But based on what we're given, it's hypotenuse leg.
What's the next page?
That's the next page. Okay? Now it says write a proof. Okay? So we are still like, if you look at the proof, right? What's the goal here? To prove that two triangles are congruent. How do we prove triangles are congruent? We now have two methods. Side angle side or hypotenuse leg. Okay? Oh, wait, three. Sorry. Side, side, side. Side angle side and hypotenuse leg. Thank you. You have three. Yeah, sorry. So the first thing I would look for is, do you have any involvement of a right angle? If you don't, then you're immediately ruling out your hypotenuse leg. It's not to say that every time you have a right angle, it's going to be hypotenuse leg. But if you don't have the right angle, it can't be hypotenuse leg. So just because I already know that there's perpendicular sides here, I would say, let's check for hypotenuse leg first. It may not be that. But if it is, at least we've narrowed it down to that. So given WY, which is marked here, is congruent to XZ, and WZ is congruent to ZY, and XY is congruent to YZ, prove the triangles are congruent. Now these triangles came from that shape. They were both part of this. So I obviously would use my givens. But then before, so which is the right angle and the hypotenuse marked as congruent, right? Before I can prove these congruent using hypotenuse leg, I need what other piece of information? Good. I got to show that two of those legs are congruent. How do I do that?
Z and Y are equal there as well.
This is the same side, right? We just split it apart, but it's the same side.
Z and Y equals Z and Y.
Good. ZY equals ZY, and what's that reason? Now I have enough information to show that triangles are congruent. And my reason, hypotenuse leg. So your proofs for these triangles are going to get mixed in together, and they're going to be able to include side angle side, 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 hypotenuse leg. And then you're going to learn two more in the next section.
Wait, can one of them be angle, angle, angle?
No, angle, angle, angle's not, yeah. Because you can have a teeny, teeny, tiny 60, 60, 60 triangle. Like think about an equilateral, equiangular triangle. Can be super small or huge. They don't all have to be the same size. Yeah. All right, so we're going to stop there. That's both sections, okay?